So which one is my favorite tangent half angle? The middle one is correct. Why? It has the most simple denominator in it. So if I get to choose which one I use, then I like to choose that one because, again, I'm going to have sine down here, so I might have a square root or something, but I won't have to worry about a conjugate. Like on this one, if I have 1 minus, suppose cosine, we get square root of 3 over 2. I got a fraction and a conjugate and a square root down there. So this one just looks bad, so we'll just stay away from the top one. All right? So let's see how to apply them. Are you okay? I'm going to come over here in the side and work each one, I think. I'll be able to work it underneath. Now, cosine of 15 degrees, again, when we saw this on the last unit, we had to type in our calculator. Now, we'll be able to, without a calculator, compute an exact value. Now, notice we can also do this with sum and difference. So I will be specific on your quiz and your assessments in here, saying use half angle identities to evaluate or use sum and difference identities, because I will get an equivalent answer if I take cosine of 45 degrees minus 30 degrees. But the cosine of 15 degrees is not on the unit circle. Okay, but my goal is to make it so the unit circle is helpful for me. And so what I want to do first is I want to write 15 degrees. Hopefully, if they give you this in this section, it's going to be half of one of our nice angles. It is half of 30, all right? So first order of business is I'm going to rewrite this 15 degrees as 30 degrees divided by 2. Any questions where that came from? I could have, but we're doing half angle identities. Otherwise, I'd have to derive the quarter angle identities. And so, which could be done. You just do 2 half angles, I guess, a double square root of 4th root. Okay, sorry. All right. So, what does my formula say for cosine of, what did I use? Did I use theta over 2 or a over 2? I used x, I don't even know. All right, so for x over 2, what did it say? Oh man. Of x. What's in my x position? 30 degrees. So the good news is that we're going to be working with something that's right on my unit circle. I can pick a value off of over 2. Bad news is I'm going to want you to simplify it. Good news is you guys all had great algebra teachers, I'm sure. All right, so first order of business is going to be cosine of 30 degrees. Square root of 3 over 2. So I get 1 plus the square root of 3 over 2. What about this 2 on bottom? Is that underneath the square root? It does not cancel the other 2. But the 2 is in the house, though. Okay. And that's your answer. Is it? As long as I don't have a square root on the bottom or a fraction inside of a fraction, I'm good. I have both. Yes, it governs both of them, the numerator and the denominator. I don't want to square it because that will change the value of this. I want to multiply by 1. Exactly right, Victoria. That's what I want to do. I'm going to get rid of this complex fraction, or I can think of it as I'm going to rationalize the denominator. Rationalizing the square root of 2, I just need to multiply it by the square root of 2, correct? Let's see what happens with this, okay? I have plus or minus square root. Okay, so I'm going to distribute the square root of 2. So square root of 1 times square root of 2. Square root of 2. Okay. All right. Sorry. Okay. Square root of 3 over 2 times the square root of 2. Square root of 6 over 2. I agree. Good. I got the square root of 2 times the square root of 2 on the bottom, which is square root of 4. Gives me 2. Yeah. So then obviously after this, all we have to do is leave the square root on top. Square root of a square root is perfectly fine. And like Victoria said, the square root is governing the bottom. I can take the square root of 4 and do this too. Do we make up another one? Let's do another one then. Oh, let's do it. Let's do a sine one. Yes, you can. I'm just gonna. Oh, good question. So the question is it going to stay plus or minus? I don't think it should because we're just taking cosine of an angle. That has to be positive or negative, right? It's positive? It's in the first quadrant. Go back to the very beginning right here. This is in quadrant 1. Cosine, everything's positive in the first quadrant. So yeah, it's just going to be a positive. You can't do that at the beginning. We can do it at the beginning of this one. All right, sine of what angle? Give me half of a nice angle. 38? Let's do something bigger. 120 is still nice, so. Is it? I mean, 270 is still a nice one, though. I got one. Leave me alone. Leave me alone. Switching colors mid-problem here. Look at that, 112 and a half degrees. Half of a nice angle. Oh, were you just giving me a nice angle? I thought you guys were spitting off just the half angle you wanted me to use. I'm like, all right, so anyway. All right, so you guys said that you wanted to go ahead and establish the sign first. I think that's great for sine and cosine. And if you're using that weird tangent formula, let's go ahead and establish that sign first. So is it going to be positive or negative? It's positive, right? We're just using the 112.5 degrees, and so that is in the second quadrant, in the stripper quadrant, so it is positive. So I throw a plus right there just to help me remember that I've already established that. All right. So this is going to be 1 minus. Well, this 112.5 is half of a nice angle. 225. So I need to use sine this time? Is that correct? Cosine, but it says sine.
You know, I didn't make the equation, Mr. Lovelace. You gave it.
All right, over 2. Any questions where that came from so far? So I'm going to get rid of the plus sign now. I already established it. Not having anything out there means it is positive. Cosine of 225 degrees. Disagree. Negative square root of 2 over 2, right? Okay, because 225 now is in the third quadrant. So a negative square root of 2 is just a positive square root of 2 over 2. Okay, leave myself a little space there so I can multiply it by 1. So distribute the 2 right there. 2. What's square root of 2 over 2 times 2? Square root of 2. And then 2 times 2 on bottom is all over 4. We made it. They do not, because there's a plus sign next to it. I cannot undo division. It's not, so please don't do that. Yes. I can't undo this division when there's addition. If it was 2 times the square root of 2 over 2, yes, I could cancel it. All right, let's do this tangent one. Say it again. No, you multiply it by 2 over 2 to clear it of this fraction. It's over 2. And it will be over 2 because it's all going to be off the unit circle, which is all over 2. It's going to be from that sine, cosine, tangent table. Multiply it by 2. Yeah. All right, tangent 5 pi over 12. Oh, we switched to radians. If you want to switch degrees, go for it. I'm not. So this tangent of 5 pi over 12 is half of what nice angle? 5 pi over 6? You agree to take 5 pi over 6 and half it, you get 5 pi over 12? You just multiply the bottom by 2. Right. 5 pi over 6. Okay. So now we get to choose whichever one of the, you want to do my favorite one? I'd appreciate it. All right, so if you want to work a different one, please work a different one. We'll see. We should get to the same point with the same answer. So what's on top of my favorite one? 1 minus cosine of this. What's on bottom? Sine. It's not plus or minus on this one. The signs will come out accordingly since we're not dealing with that square root. All right, cosine of 5 pi over 6. Negative square root of 3 over 2. You're the one that won the Kahoot on this. All right, cosine pi over 6 is square root of 3 over 2. We're going to the second quadrant. So signs don't think positive there. So I need to change this. It's going to be minus a negative square root of 3 over 2, right? So plus square root of 3 over sine of 5 pi over 6. Disagree. 1/2, right? Got a quiz coming up sometime for the next week. I'm just going to ask cosine 5 pi over 6. You got to be able to 40 points. Now what? Can't have fractions inside of fractions. Multiply by 1. Multiply everything by 2 over 2. That's going to give me 2 plus square root of 3 over 1. So this kind of looks like our tangent answers from the quiz earlier in the week. Yeah, good. Triangles want to get in on this.
Oh, you can find a triangle to go home.
Okay. Now, good news, same with the double angles, we just have to draw one triangle. And I'm going to draw this triangle in what quadrant? Third? Third quadrant? Okay. All right, so my theta's up here. All right, so I've used this information. What's that 8/15 going to tell me? Opposite over adjacent. Opposite over adjacent. It doesn't, because remember sine and cosine have to be between negative 1 and 1. So opposite over adjacent? Opposite. No, it's not. It's positive. Bree says we should throw in some negatives. Negatives always make the world more fun. Except for negative people. Don't be a negative person. So help me out with that hypotenuse, please. Pythagorean triple. 17? 17? And so since everything else was negative, this should be negative as well. So radius is the distance. Awesome. You guys listen so well. All my classes listen this well. Teach forever. So sine of theta over 2. Oh, it's going to get tricky here in a minute. So I got the plus or minus the square root of 1. Is it plus or minus? Cosine of theta. What's cosine of theta? Disagree. Negative 15 over 17. You were. Hang on a minute. So negative 15 over 17. Can I call that positive 15 over 17? It's minus a negative 15 over 17. We'll get there. We'll get there. 1 plus 15 seventeenths. $32 seventeenths. I agree. Okay, multiply by 1/2. Okay, what's that give me? I do. 32 over 34 is 17 times 2. Does that reduce? 16 over 17. 16 to 4? Wow. So square root of 16 is 4. Square root of 17 is hanging out still on bottom, so I rationalize it, and I get an answer that Mr. Lovely is still going to take his red pen and count off because it can't be plus or minus. It has to be plus or minus. It's negative. It's in the third quadrant. What's in the third quadrant? Huh? It is. We're finding sine. I disagree. I say it's positive. Do you? She's exactly right because it's half. You're telling me what quadrant theta's in. What angle did you just find? You found half of theta. What's half of theta? Well, let's divide it. Let's divide it by 2. What's half of 3 pi over 2? 3 pi over 4. What's half of pi? Pi over 2. If theta over 2 is between pi over 2 and 3 pi over 4, what quadrant are we in? Quadrant 2. Stripper quadrant. Why not? You try it. You work it with cosine with your pod bods and see if we get the same thing. It's positive because we're in the second quadrant. Theta over 2 is in the second quadrant. Theta is in the third quadrant. If I take half, look at it this way. If that blows your mind, if I take half of this angle, suppose it's what? I'm going to make up an angle that will work. 210 degrees. Half of 210 degrees is 105, right? So that means half of this angle is only going to go around to right here and be in the second quadrant. Okay? All right, so you try cosine of pi over 2, and if you're watching this video, just come back and hit play if this video even gets published ever. I don't know. All right, yeah, for tangent, I'm going to skip tangent. Use the tangent one that doesn't have the square roots in it, my favorite one, and it will be pretty straightforward. I want to get